Welcome to my video on variance and standard deviation. So in a previous video, which I've got a link to in the back, we talked about how to find out the spread of data. We're giving several data points. We're trying to get an idea, some parameters to describe it. First thing we did in the last video, we did the mean, and that gives us some idea about where the center of the data is. We also calculate the median, which gives us another bit of information. But what we saw is that when you have very different data sets that can have the same mean but look very different as far as the spread goes. And we also calculate the range, which is the minimum and the maximum. Now in this video I want to concentrate on the variance and standard deviation, which also gives us more information about the spread of the actual data. The idea here is if you've got 1,000,000 data points and you're trying to understand what they all mean, the mean, the mode, the range, the standard deviation, the variance, they give you some idea of what you're looking at. So that's why we're trying to do that. So what is the variance? The variance measures the average squared distance from the mean, and the symbol is the sigma squared. And so a large variance equals more spread in the data, and sigma here, mu, that is our mean of the data. So here's our formula. There's our variance. Now we're going to sum from I equal 1 to n, however many data points we have, 1 to, if we've got 1,000,000 data points, it could be to 1,000,000. X of I is the individual data point. We're going to subtract off that the mean, and now we want to find the square of that distance, so we take the square, so it's always positive numbers. And then we divide by the number in the data set, whether it's 10 or 1,000,000. And that gives us a numerical value of this variance. That tells us something about the data. What is a standard deviation? The standard deviation is the square root of the variance. They're closely related. It's just the square root of it. And the idea here is it brings us back to the original units. If you're measuring in feet, inches, miles, kilometers, centimeters, meters, ergs, whatever the units are, that gives you it's interpreted as a typical distance from the mean. So that gives you some information, but it puts in the original unit. So that's our standard deviation. Do an example. We've got 5 data points, 80, 85, 90, 95, and 100. We're going to use this formula right here to calculate our variance. So we know the mean, if we add up 80, 85, 90, 95, 100, that's 450. Divided by 5, that's 90. So the average or the mean is 90. Now the deviations, calculating these deviations right here. So the first one is going to be 80 minus the mean is 90, so that's minus 10, so that's that right there. The second one is going to be 85 minus 90, that's minus 5, and then 90 minus 90 is 0. And then we've got 95 minus 90, which is 5, and then 100 minus 90 is 10. So there's our differences right there. That's that term right there. Now we square them, they all become positive numbers. Now we add them all up together. So the square deviations are the 100, 25, 0, 25, and 100, these numbers over here. Add those together, that's 250. Now the variance, as our formula shows, is the sum of these differences squared divided by the number. So the sum was 250 divided by 5, so that's 50. And we know the standard deviation is just the square root of 50, which is 7.07, and there's a continued fraction. So how do we interpret the standard deviation? A small standard deviation, values are close to the mean. This would be like in this distribution here. Say like you've got a test scores of a bunch of students that are about the same. It could be very similar grades. And then from a large spread of data, this could be give the same test to a very large population of just people from all different walks of life and educational backgrounds. You're going to get a much different, wider spread. And so a low standard deviation exam scores means consistent performance. In other words, they're all about the same or similar. Now, an example where it could be extremely wide would be like in YouTube videos. You're watching a YouTube video, and some they go viral, and they've got huge numbers of views, and some don't go viral. Most don't, matter of fact, and they have very low viewership. And so that gives you a very big spread in the number of observations or views. So our summary here are our key takeaways. The variance is equal to the average squared deviation from the mean. The standard deviation is the typical distance from the mean. And the standard deviation is a core measure of variability in statistics. You'll see this number a lot, or the standard deviation discussed a lot. So it's a good thing to learn. I hope you got something out of this video, learned about variance, deviation, standard deviation, and how to characterize a data set using some of these numbers. Thank you for watching.